Hello guys, welcome to my YouTube channel. My name is Dinesh, currently studying at Sri Venkateshwara College of Engineering, pursuing the degree in Computer Science Engineering and the course Cyber Security. The subject we discuss about is mathematics and the topic is ANOVA techniques and basic principles. ANOVA techniques and basic principles. Welcome to this introduction to ANOVA, a powerful statistical tool for analyzing differences between groups. This presentation will explore its basic principles, common types of ANOVA, and how to choose the right technique for your research. Introduction to ANOVA. What is ANOVA? ANOVA, analysis of variance, is a statistical test that compares the means of two or more groups. It determines if there is a statistically significant difference between the groups' means or if the differences are due to random chance. Key concepts of ANOVA. In this, we will discuss about the ANOVA partitions, like the total variation in the data into different sources of variation of ANOVA, such as between group variation and within group variation in ANOVA. So here we'll understand the one-way ANOVA technique. So number one independent variable. Number two, multiple groups. Number three, and the last we're going to discuss about the example of ANOVA. One independent variable. The one-way ANOVA examines the effect of a single independent variable on a dependent variable. Multiple groups. The independent variable has at least two groups, allowing comparison of means across those groups. Example, investigating the impact of different fertilizers. Group 1 fertilizer, Group 2 fertilizer, Group 3 fertilizer on crop yield dependent variable. So here these are the assumptions of one-way ANOVA. Here we discuss about normality, homogeneity of variances, independence. So we'll discuss now about normality. Data within each group should follow a normal distribution. Homogeneity of variances. The variances of groups should be approximately equal. Independence. Observations with each group should be independent. So this is ANOVA table. So you can see the different types of results we're getting: F static, P value, and post hoc tests. Interpreting the one-way ANOVA results. F static measures the ratio of between group variance to within group variance. A higher F static indicates greater between group variability. P value represents the probability of observing the observed difference in means. If there were no true difference between the groups, a low value, typically less than 0.5, indicates a statistically significant difference. Post hoc test, used to identify with specific groups, differ significantly from ANOVA results. Two-way ANOVA analyzing interactions. So we have here three parts divided. Number one, two independent variable. Number two, example for two independent variables. Number three, interactions of ANOVA. Number one, two independent variables. Examines the effect of two independent variables on a dependent variable, allowing for the analysis of interactions between the variables. Example for two independent variables: testing the impact of different teaching methods. Group 1 traditional, Group 2 interactive, and student motivation. Group 1 high group and Group 2 low on test scores. Number 3 for two-way ANOVA. Interactions, when the effect of one independent variables on the dependent variables differs across levels of the other independent variable. So here the total we're going to discuss about assumptions of ANOVA. Assumptions of two-way ANOVA. Normality. Data within each group should follow a normal distribution. 2. Homogeneity of variances. The variances of the group should be approximately equal. Number 3. Independence. Observations within each group should be independent of one another. Homogeneity, heredity, and something called that. Interpreting two-way ANOVA findings. 3 groups, as we have discussed: main effects, interaction effects, post hoc tests. Indicates whether each independent variable has a significant effect on the independent variable. Number 1, done. Number 2, interaction effects reveals if the effect of one independent variable on the dependent variable is different at different level of the other independent variables. Post hoc test used to identify specific group difference and main interaction effects. Next, ANOVA with repeated measures. Repeated measures used when the same participants or subjects are measured multiple times under different conditions or at different time points. Example, measuring participants' stress level before, during, and after public speech task. Advantages: increase statistical power and reduce use of some participants. Selecting the appropriate ANOVA techniques. Number 1, independent variable. Number 2, data type. Number 3, research questions. So we will discuss here independent variables. How many independent variables are you investigating? Number 2, data type. Are your data between subjects or within subjects? Research questions. What specific difference or interactions are interested in exploring? So that's it for today, this video. Thank you for watching the video.